Raytheon Technologies has been building payloads in space to perform Earth observations literally since the first one. TIROS stood for Television and Infrared Observation Satellite, and it was the first weather satellite to help us understand our Earth ecosystem. We've developed a couple for NASA and NOAA over the years. MODIS and VIIRS are used to make observations of the Earth that help reveal what's going on with our planet. And in some cases, that's looking at things like the greening of our planet to understand things like vegetation indexes. These are important not only for understanding crop yields in the United States, but it could be crop yields in foreign countries to help partner nations better utilize the finite resources they have for providing food for their citizens. So there's a very positive impact to doing that. And then there's actually, strangely, a defense impact to that. Because if you have a country that has the ability to feed its own citizens, generally it winds up having a little more political stability. So there's reasons for both defense and civil applications to leverage observations that come from the MODIS instrument and the VIIRS instrument. MODIS actually flies on two NASA EOS missions. The first one is called Aqua, and the second one is called Terra. VIIRS is flying for NOAA on SUMI MPP and NOAA 20, and there are 3 more VIIRS instruments scheduled to be launched on JPSS 2, 3, and 4. You know, in Raytheon Technologies, we literally do go from photons to forecasts. And when I say that, I mean from the payload on board the spacecraft itself to the ground system that receives the data from the spacecraft, to the processing of that data, to the meteorologist software and console that produces the forecast that you're going to use. All of those are Raytheon programs. Raytheon has been part of Earth observations in the Landsat program for many, many years. And in fact, we built the payload for Landsat 7. And really, to understand how Raytheon participates in Landsat, you really need to understand what the mission of Landsat is. It's a USGS government program working with NASA and NOAA to better understand what's going on with the surface of our planet, and specifically things here in North America, to provide high resolution imagery that helps reveal the health of the surface of our planet. So Landsat 10 is going to be an exciting program, and Raytheon Intelligence in Space has been investing in technologies that have helped us develop a prototype imager called ATLAS, or the Advanced Technology Land Imaging Spectroradiometer. What's really great is that we've been able to leverage all of our past performance and work on other NASA NOAA programs to reduce the size, weight, and power of our payloads and increase the data quality that comes out of it. So we're giving even better data with an even smaller instrument. We've used that advanced technology to shrink the telescope size on those imagers and make the overall instrument not only smaller, but much more affordable. So what's really neat about the Joint Polar Satellite System is it's exactly that. To be able to image the entire Earth and really understand the entire Earth system, it would be cost prohibitive for US taxpayers to bear that cost by themselves. So there is a treaty called WMO 40 that allows us to freely share meteorological data all around the world. And those that participate in the Joint Polar Satellite System, they each provide a contribution to a global perspective of observations that are then used within the United States by NOAA, the National Weather Service, NASA, and other government entities. The key here is that we've shared the observation times. So when you look at our VIIRS instrument that's flying on SUMI MPP and NOAA 20, it flies in an early afternoon local time ascension. That means it rises over the equator at 1:30 in the afternoon. What's unique is that it doesn't matter whether you're in London or Lisbon or Los Angeles. It's always going to rise over your back with the sun illuminating the Earth at 1:30 in the afternoon. This continuity of observations happens because the satellite essentially stays in the same orbit. It's a 101-minute orbit to go from the North Pole around the South Pole and back to the North Pole, and the Earth turns underneath you. So when you look at that orbit plane, you'll get 14 orbits per day for a VIIRS instrument flying on a satellite, and that images the entire Earth. And that allows us to bring technology and science down in a very meaningful way with very high resolution at a very affordable price point, because we're performing one observation and other satellites performing other observations. So Raytheon Technologies has leveraged all of our past performance and past programs, and we've invested both our internal research and development dollars and also government dollars from studies and study contracts to develop the next generation of capabilities that we're going to need to have to stay ahead of the game when it comes to understanding weather and climate on our planet.